So let's go ahead and look at some security issues. I'm going to start by creating a new project, and I'm going to put all of my cryptology code in this project and get everything working first, and then I'm going to move it over into the password manager. So let's call this crypto, and we'll stick with the usual stuff to start. Okay, so here's our project, and we can go to the Java code and go to the main activity. And in my main activity, I'm going to create a private string called mPassword, and I'm going to initialize it to the value swordfish. So the question is this safe? Is it safe to put my password as a member variable inside my main activity and initialize it? Well, let's find out. So I'm going to go ahead and run this app, and that will cause the application to get built. And I'll run it on Genymotion this time. And here's my hello world. And so the question is this safe? Well, let's go to the project folder, and under crypto app build outputs APK, we have the two actual APKs. This is what gets pushed to the Android device when you go to run it. And this APK here is actually just a zip file. So if I make a copy of it and change the extension to .zip, then I can uncompress this file So what I want is actually in this classes.dex file, and that's where my code lives. And I'm going to right click on that and edit it with Notepad. And it's a binary file, so it's got a lot of junk in it. But if I do a find and search for swordfish, I see that swordfish is contained in plain text inside of this big binary file. And if I go to the trouble of disassembling the code and tracing through and figuring out what's going on, potentially I can find that password in plain text inside of the application binary. So what we've learned from this is that no, merely putting the password as an initialization variable or initialization value for a member variable is not safe. So let's not do that. So I'm going to override the onDestroy event. So that when my app gets killed and then restarted later on, I can save the password in my shared preferences and then get the password back later on. So first I want to get a preferences, shared preferences prefs is equal to get preferences, and then I'm going to make this mode private, so it should be completely safe. So nobody can see this except my app. And then I'm going to get a preferences editor. And then I'm going to put my password in the shared preferences. And I'll put this under a password key. And here will be my password. And then I'm going to commit that change. And then I could pick it up on the other side and on create. I could check to see whether there's a value set in my preferences and then restore the password from that. So even though the user hasn't, even though the user has entered the value in the form instead of using it as a static initializer, well, I still have the text here in plain text, so it's going to be in the binary, but ignore that. let's see what happens with this preferences. So is this safe? And this time I'm going to run it on my Asus Nexus 7. And the app is running, so I'm going to exit out of the app. So according to the security model, any preferences that are mode private associated with my app are supposed to be secure. So let's go and actually log on to the device and see if that's true. So I'm going to start a command window, and I'm going to cd to where ADB lives, which is in wherever I've installed my SDK, users, mark, app data, local SDK, Android SDK. And then there's a platform tools under the SDK. And then ADB lives there. So I can say ADB devices. And this is my actual Asus Nexus 7. And this is the Genymotion emulator. And then I can create a shell on either of these devices. So I have to say which one I want. I want this one. And then I'm going to launch a shell. So now I'm logged into my Android device. And if I go to data/data, that's where the internal apps live. I don't have read permission on the directory, so I can't list anything. Now, I know the package name here, which is com.example.mark.crypto. And so the app is actually installed in a folder inside of data called com.example.app.mark.crypto. And I can CD there, but I can't ls anything. And I can't look at the shared preferences. And neither can any other app that's running on this Android. So you may think this is pretty safe. It's marked mode private. I can't access it, don't have read permission. But I've actually rooted this device. So if I type SU, I am now running as root on the device. And now if I do an ls, now I can actually see the contents. And I see there's a shared prefs folder. If I cd to shared prefs, I see there's main activity.xml, and if I cat that, wow. So here's the value that I just added. I added a password key and the value swordfish. So I can see this in plain text now because I have root access to the device. So the bottom line here is if you use shared preferences to store sensitive information, even though the security model says that these things are private, anybody who gets a hold of your device and gets root access to it can actually look at anything that's stored in your shared preferences. So that's not safe either. Now, the only real safe way to store information across on, destroy, on, create is inside the bundle. So I'm going to get rid of that. And this time I'm going to override on-save instance state. It's actually public void on-save instance state. And this gets a bundle called save instance state. And I'm going to go ahead and paste this code in, but instead of using shared preferences, I'm going to put the value on my saved instance state. And I don't need to commit. I do have to call super.onSaveInstanceState to actually save those changes. So now I'm saving it anytime the app gets destroyed. And then on this side, I'm going to get it back. So string, first we'll see if saved instance state is not equal to null. Create a string called recovered, which is equal to saved instance state dot get string. Use the same string value. And then I'm going to log the recovered password. So this time I'll go ahead and run it on the Jenny motion so you can see what I'm doing. So I'm going to go ahead and rotate the phone, and I see the recovered password swordfish, so I've definitely maintained it across destroy and create. But then the question is, what mechanism does the operating system use to store this bundle? Does it get saved to a file or not? If it gets saved to a file, then anybody who has root access to the device should be able to see it. And I've done some digging around, and basically what happens is there's an activity manager service, and when you bundle this stuff up and store it, it basically gets passed over to the activity manager. And then when the thing gets restarted, it gets the information back from the activity manager. And according to everything that I've seen, it's not entirely clear, but according to everything I've seen, that information only lives in RAM, only lives in memory. So nobody who has access to the device can see it on hard disk. So yes, this seems to be safe, but then the question is, do I trust it? Well, not entirely. I think in addition to saving the password, you probably want to encrypt the password first, so that even if somebody gets access to the device, and even if it does get flushed out somewhere, it's still not going to be in any format that's going to be easy for somebody to recover. So the bottom line here is anything that you put into a shared preferences object needs to be encrypted in a way that's impossible for somebody to recover. And even anything that you put in a bundle and you save instance state on, that should probably be encrypted at least minimally as well, so that it's harder for somebody to recover it.